Hello, welcome everyone, welcome back to my channel. Today we are doing circle theorems, but before that I'm running GCSE revision classes, and it's just the booster classes, crash course classes, and they're really useful. I've been doing it for the last 3 years and have produced great results. Don't worry if your grades are lower, predicted grades are lower, don't worry, you can just enroll here and definitely you will see the improvement. Apart from it, GCSE classes are at just £6 per hour, or if you are looking for any class for any subject from year 1 to A levels, just drop us an email at exactacademy@gmail.com. Also, if you're looking for the free worksheets, free theory sheets that are available there on our website, which is exactacademy.com. So let me start with the circle theorems, and here we will be doing proofs. This is part 1. I'm doing few circle theorems in it, and the rest of the circle theorems will be doing in the later parts. So first one is, before I jump onto a particular circle theorem, there is one term that I have to discuss, which is called arc. Well, that I have already discussed when we did arcs and circles, but I'm doing it once again because this is very important, and the word is arc. So arc is, let's say this be A and this be B, these 2 points. If I join these points, then this is called arc. The important thing is, arc is the part of the circumference, the simplest definition. Most of the time when I ask students, they generally say that circumference, or they're not able to put together the words. It's simple. It's a part of the circumference of a circle. So that is your arc. And subtending an angle by arc, that means this arc is making an angle. Making an angle, that means, say for example, this is a point C. So we know to make an angle, 2 lines are required. So these 2 lines are actually given by this arc, because arc has 2 endpoints, and this and this are the endpoints of that arc. That means this arc is subtending angle at C here. That's called subtending. So if you ever see this word subtending, just don't get confused with it. So our first theorem is angle at the center theorem. So angle at the center theorem says angle at the center is always twice the angle at the circumference. Or there's another way of saying this theorem, or another statement you will come across, is that it says that when an arc, or you can say an arc, that it subtends an angle at the center is always twice that it subtends at the circumference, and that's why the word subtending is important. So this is AB, and let's say this O be the center. So this arc is making an angle at C. Here, this at C. And let's say this angle be X. Now the same arc, the arc has to be the same. Okay, now the same arc, now it's making an angle at the center. So this angle that it's making at the center is always twice 2x. And that's your theorem. It says angle at the center, or angle subtended by an arc at the center, is always twice at the circumference. So I'll be writing the angle at the center is twice at the circumference. The important part is, whenever you are doing geometrical proofs, any kind of like proofs in the sense the question is given related with the geometry, always give your reasons why you did so. If suppose in the question is given as 30 degrees and they're asking you that what is this, don't just write 60. It won't work. You just have to give reason that this is because of this theorem. And also just don't write circle theorem 1 or circle theorem. It won't work. You have to write down the theorem. Oh, this is called angle at the center theorem. So if you're writing angle at the center theorem, but I would suggest obviously writing the statement is much more appreciable or workable. So it's better, rather than writing an angle at the center theorem, I would suggest write down angle at the center is twice at the circumference. You will definitely going to get your marks. This is your circle theorem first. Let me see the proof. So we know we are proving that if at circumference it's x, then at the center it has to be 2x, which means this here x is already given, and we have to prove this to be 2x. For that, I'm just joining this one, and this is O, this is C. I have divided this into two triangles. This is triangle 1, this is triangle 2. Now look at the triangle 1. That means I'm talking about this triangle. If you see this triangle, let me write down in triangle AOC. Let's say, okay, rather than saying x, I would say, let be this angle, this smaller angle be x, and this smaller angle be y. Obviously x plus y will make the complete angle, but I have divided this into x and y. If you look into the triangle AOC, OC is equals to OA. Now just pause here and think, why is it so? Why they both are equal? Well, they both are equal because they both are the radius of the circle. You have to do the mindstorming, your brainstorming. It's very important. If you are looking, or if you're just watching the videos, or if you're listening your tutors or your school teachers and just thinking that, okay, you got everything, it won't work. Whenever someone is teaching, try to think, why is it so? Because it will help you to do more analytical things. It will help you in making your analytical reasoning part more stronger. So say for example, in exam, any question which is somehow out of the box or like little bit complicated is there, you will be able to do it. Else, if you are cramming things, okay, this question is like this, then I'll do it like this because this is this, because I teach students. So I know there are a lot of students, they think, okay, this question is done by this method, this trick. So like any question which is somehow related to it, I'll be doing that. This is called cramming, learning. Maths is not about learning. It's about understanding the concept. Because in theory papers, you will be seeing the same question. Say for example, in physics, you have studied what is half-life. So they will be asking you what is half-life and you will be writing the definition. Obviously, for the theory part, I'm saying. And even if they give you something little different, but you can join all that together because that is there in the book given. But for mathematics, they can give you the question which you haven't studied. Maybe they can give you question from anywhere, and maybe the question in which there will be like 4-5 concepts you have to apply all at the same time. So that's why understanding is very important and brainstorming is very important. Coming back to this question, so OA is equals to OC, then again think that, pause this video and think that why is it helping me? I mean, for this triangle, what kind of triangle is this if these two are equal? This is an isosceles triangle. So triangle AOC is an isosceles triangle, which means that this is the property of an isosceles triangle, that two opposite angles of two equal sides are always equal. So if this is x as well. And now I'll be applying angle sum property. If you're not aware of angle sum property, what is it? It's just that sum of all the angles of a triangle is 180 degrees. So which means angle O plus angle A plus angle C is equals to 180 degrees. That means angle O, or more specifically, I'll be saying angle COA is 180 minus 2x. So this is 180 minus 2x. Obviously, if I apply angle sum property, that means sum of all the angles of a triangle is 180, and if two angles are x and x, so third angle is 180 minus 2x. And similarly, in triangle OCB, which is this triangle, the other half, if this is OC is equals to OB is equals to radius, obviously here also they both are radius, which makes triangle OCB an isosceles triangle as well. And this is, if this is an isosceles triangle, so obviously this is going to be y. And this is why, then again, applying angle sum property, this turns out to be 180 minus 2y. Now one more thing. If I say this whole angle, because this whole, these three angles, which three angles? This 180 minus 2y, 180 minus 2x, and this third angle, if I add them all up, it will give me 360, because angle in a whole circle, that is your 360 degrees. So I'll be saying 180 minus 2x plus 180 minus 2y plus your third angle, which is angle AOB. Whatever I'm saying, look at the diagram and try to find what I'm saying. If I said AOB, so see which angle is AOB. Angle AOB. This is equals to 360. So from here, angle AOB is equals to 360 minus 180 minus 2x, because you're subtracting. So 360 minus this whole, that will give you 2x plus 2y. So I got this angle as 2x plus 2y. This angle is 2 times x plus y, and this angle is, if I add, will give me x plus y. And that's what we have to prove. That angle at the center, this one, this is angle at the center, which is 2x plus 2y, and this is at the circumference. So center is always twice at the circumference, and hence we have proved it. So what we proved, that angle ACB is x plus y, and angle AOB is 2 times x plus y, and hence we proved our theorem. Moving on to our next theorem. Our next theorem is called angles in the same segment theorem. So what it is angles in a same segment theorem. And its a statement says that angles in the same segment are always equal. So this is an arc. This arc is subtending an angle at one point on the circumference. Let's say this point be C. Now, this point, this A, they are again subtending angle at another point, and let's say this point be D. Now, important thing is they both are subtending, the arc is same, and they both are subtending at angle at the circumference. So if this angle is x, this angle will also be x, and similarly, it doesn't matter wherever they are subtending, all the angles will be equal, which means now A and B subtending angle here, so definitely this is also going to be x. Even if they are subtending angle here, then also we'll get the same answer. So angle in the same segment, they are equal. Now one question, because AB subtending at D and C, they are equal. Now the same arc AB is subtending angle here. Will it be equal? No, this will not be equal. Because first of all, the question, like the theorem says, angle in same segment. It's not in same segment. Segments are what? Divided by the straight line. If I draw a straight line, AB. So this is called your minor segment, this part. that is between the arc and your chord. This straight line that is joining 2 points on the circumference of a circle is called chord. So this chord has divided circle into two regions. That lower one, which is bounded between the chord and an arc, that is minor arc, is called minor segment, whereas the other segment, this one, is called major segment, and that's why it's called in the same segment. So it has to be in same segment, obviously. So, and if it's like this, then that means this angle is actually subtended by this major arc. So in short, what you have to keep in mind is that it has to be in same segment, not in a different segment. Now let me see its proof. So we know it's A and B and it's subtending angle at C. Like this. Like this and this. And now another at D. This one and this one. So what we have to prove, we just need to prove that they are equal. So if this is x, we have to prove this be x as well. So let me start with this one. So what's given? Let's say given B, angle ACB is x, the one that I have shown here. This is x. Then obviously let me say this be O, which is the center of the circle, and let me join this one like this. So obviously according to the first circle theorem, which says angle at the center is always twice at the circumference, this is going to be 2x. So I can say angle AOB is equals to 2x by, you can say angle at center theorem, but write down the complete theorem. Okay, you have to give the, when you're writing, write down the complete statement. Angle at the center is twice at the circumference, but I'm just writing the heading of the theorem here. Then we know AOB is 2x. So now angle AOB is 2x. Then if this is 2x, then this will obviously be half of it by the same circle theorem, that is angle at the center. So then angle ADB is equals to half of angle AOB, which is half of 2x, that is x. And by saying angle at center theorem. And hence, if this also comes out to be x, we have proved that doesn't matter wherever it's going to be in the same segment, the angles are always going to be equal. Well, moving on to our third circle theorem, which is angles in a semicircle. So it's angles in semicircle. And the statement says that the angle in a semicircle is 90 degrees. Is always 90 degrees. That means suppose this be A and this be B and this be O. That means I'm talking about that chord which is the largest one and which is nothing, it's your diameter. So if I join it, obviously this will divide this whole circle into two equal halves called semicircle. So if you are subtending, if this arc AB is making any angle on this part, on this semicircle, or even down there in semicircle, that's always going to be 90 degrees. So let's take any point, let's say C, and if we join together like this, this angle is always going to be 90 degrees. And its proof is very simple. Its proof says, let's say angle AOB is what? 180 degrees, because we know that angle at the straight line, angle of the straight line is always 180 degrees. So if this is AOB is 180, then angle ACB is going to be half of angle AOB, which is half of 80, that is 90. Why? By same angle at center theorem. Write down the whole statement. So if this is 180, it's going to be half of it, because angle at the center is always twice at the circumference. So basically that's it for today. In this, we'll be doing the remaining circle theorems with their proofs in the rest of the videos. Also, we'll be doing questions on each so that you will be having a better understanding of these theorems. So again, if you are looking for like worksheets, free worksheets available on our website, or if you're looking for test series, or if you're looking for GCSE crash course or for the regular classes, or important thing is if you are looking for mock papers, the paid mock papers, just drop us an email at exactacademy@gmail.com. Because obviously the exams are near and maybe you're lacking in terms of preparation, and you're looking for something which will help you like quickly, like you would want like the important questions to come to you and we'll be able to do them. So if you're looking for those important questions like with summarized theory so that you can do that faster, all are available here. You just need to drop us an email at exactacademy@gmail.com and we'll coordinate from there. That's it for today. Thank you everyone. Take care.